Debashri. I go by Debbie here. I started UTA in fall 2023, and so since then I started a lab here which is named Transformative Wireless Systems and Technology Lab. We call it TWIST Lab. Right now we have pretty good amount of students in my lab. So I'm working with PhD student, one master's, and almost 7 to 8 undergrad students in my lab. So we generate teams, we assign like projects to each team, and each of the teams, they have like a structure, some graduate students, some undergraduate students. Before hiring, I try to find if they have some programming background, or they have some for undergrad students, and for grad students, try to find if they have done some project by themselves, like building the strategies to how to solve that problem. So my research is mainly about wireless communication. So that's like the end part of all the communications happen. Communication is everywhere, right? We are communicating, and that's how we are here right now. So it gives us the power to like get access to everything in this world. So now the wireless communication, it gives us the flexibility to move while you are connected to the whole world, right? All of us are using wireless communication all the time. Still, there are many things in the wireless communication domain which needs to be improved. So my research is involving or in like using AI-based technique in there, so that our different type of quality of services or different things with wireless communication haven't been used in a wide range can be used. Like one example I could give is the network robotics. So where we are trying to build a setup where we are connecting multiple robots. All the robots are AI enabled. But so far what the robots does is that they just take the decision by themselves. Yeah, like whatever artificial intelligence based decision themselves. So we are building our test bed or a technology where they will be connected with each other, and they will learn from each other, and they will take the improved decision. So I think that's what is missing right now in the world, in the autonomous system. The autonomous systems are very much like locally ingrained, so they are just taking decision by themselves. We want to make them also connected. So that's kind of one of the area where I think a lot of opportunities are for wireless communication to still make a footprint of. Recently, I received a grant which is on spectrum sharing. So the spectrum is we send data from one place to another, right? So that's what you are using your phone, you are transmitting, you are calling. So that means your voice data, whatever you are talking, that's the data that's being transmitted through the phone to another phone. How it is being transmitted? It is being transmitted through radio frequencies. So that's electromagnetic frequencies, which is, we cannot see it. It goes by over the air, right? That you can think of like as a channel. So you can think of that as a pipe. And it gives you a wide area, but you cannot use the whole area because then you are the only one in the world who will be able to talk. So it can be, chopped off. You can be used by multiple people, and so that is, we are calling the whole pipe, we are calling a spectrum, and then different part of that spectrum is allocated to different people. Organization which we call Federal Communication Commission, they actually have allocated different range part of that pipe or spectrum to different people. So like if your operator is T-Mobile or Verizon or AT&T or whatever, they have bought a specific part of that whole pipe. That part is being used by millions of people. So how to ensure that your data doesn't get lost? Your data is being successfully, reliably transmitted to the other part. That's the challenge right now we are facing, because that's our spectrum is fixed, right? But we are growing. Our communication devices are growing. So that's why the agency FCC came up with some shared spectrum. So there are some spectrum or some part of that whole pipe which is allocated for military usage or something like that, where they are not being used all the time. So they opened up some part of it, and my grant, my research is about how we can intelligently use that. So how we can use machine learning based algorithm, like object detection based algorithm, to scan that spectrum all the time and figure out if there is a military communication. So that's how fast we can catch it, how reliably we can catch it. So that's mainly my recent grant is about.